Alright, and I'm back. Looks like no one's actually on the stream yet, so I'll just be talking to myself for a little bit. I've been away for a bit. I covered some updates in the last stream last weekend, which is not going to be on YouTube. So for those of you just catching up, I would just look down below on the Twitch panel and possibly on the YouTube video description. It'll show what's going on right now. The thing I want to point out most right now, before I actually get started, is that we have the Sega Saturn 25th Anniversary Game Competition that I'm hosting via the Sega Extreme forums. Let me go ahead and try to pull that up so that I can show you what's going on here. There we go. Okay. So, you'll find in the description down below, Twitch or YouTube, that we have the link to the Sega Saturn Anniversary Game Competition. So this year is going to be the 25th birthday of the Sega Saturn. That's... Oh, hey Shane. I'm just doing one quick recap update before I actually get started. I want to just show everyone that we are still polling for the Sega Saturn 25th Anniversary Game Competition. So if you pop over down in the description, one of the first links you're going to see is that link to this forum post on the Sega Extreme forums. That's where a lot of us Saturn homebrew guys like to hang out. You'll find that right now we're polling for the theme for the game competition. I mean, in this case, the theme is going to be kind of optional because we're just looking for everyone to submit what they want to submit. But, you know, trying to get everyone to attempt to be on a theme is nice. The poll is going to close for the theming on August 15th, at which point I'll make an announcement. It's going to be on the stream the next day, on the 16th. You'll actually, if you go down in the Twitch description below, you'll actually see that I actually have a real schedule now, describing what's actually going to happen on these days. So here's the plan, really, for this game competition. Once we announce the theme, there's going to be 3 months of being able to work on whatever game you want to work on before submissions close on November 15th. And then as long as everything's submitted on this forum post, like a link to the ISO or an attached ISO on the post itself, the community will be able to download the ISO and play it via, you know, a pseudo Saturn Kai, an emulator like Mendefen or Yabase, or however you pronounce it. Perhaps maybe I'll be able to play it on a Sadiator, I don't know. Then after a week of playtesting, there's going to be, you know, throughout that week, there's going to be another poll. People are going to be able to vote on their favorites, and then the winner is going to get a tiny cash prize. Right now, I'm using what little Twitch subscription money I have to fund that one. So right now, it's $20. If I get some more subscriptions or tips or butts or whatever you call it, that pot will grow. So we got until November to sweeten the pot to try and encourage more people to participate in this game competition. I'm just trying to encourage people to, you know, dip their toes into game development, even if you're just making a crappy Tetris clone. It's nice to see someone trying something new on the Saturn, because eventually someone's going to stumble into a thing that they can do pretty well that hasn't been done on the Saturn, at least not in North America, or it's nice to have, you know, a little bit of new content here. I'd like to be able to play some new games on my Saturn. With that said, I'm encouraging everyone, even people that only like to spectate on programming, to go ahead and give it a shot and try it out, because, you know, entry is free. Joe Engine makes it pretty simple to try and get your ground floor, you know, get your feet wet on the ground floor. You know, a quick, dirty little 2D tutorial. I mean, he's already got basically 2 functional 2D games as kind of like examples to base your code off of that you can expand on. So really, the only reason why you wouldn't participate is because, you know, you don't enjoy the coding. Yeah. How to remove? Well, I mean, depending on the turnout, maybe people like it's the winner's going to be chosen by public poll. Hopefully, it doesn't get gamed. I'm assuming the community's honest enough not to try and figure out a way to break straw poll. But no, if people really like your port of Doom or Tetris clone or whatever you're planning on doing, could turn out to be a winner. I might have to owe you $20. I don't know. Okay. Well, that's what's going on. You can see Ponut is It's giving me some feedback there, but I'm hoping to see a lot of new content from people that learn off the stream. In the meantime, let's actually get back to work on my stuff. So, this is going to be... okay, one last update. This is probably going to be the last week for a little bit where I'm actually going to be working on my personal game, Seniriu. What I plan on doing is I'm going to finish up this 3D collision code and try to get it working in 3D as opposed to just 2D, which is what's happening right now. We're going to have to do a little bit of review to see what's actually going on because I need to refresh myself. Once I get this fixed up, what I'm going to be doing is I'm going to be focusing my efforts for the next month on a 3D editor that that is based off of XL2's Z-Dream tools. Now, XL2, over the last month, has been kind enough to upload not only an updated copy of the source code for Sonic Z-Dream, which is the game he submitted for Sage, I believe, last year or the year before, but he's also updated his model converter with an OpenGL preview, which will be very helpful for people that want to make 3D figures to upload into Saturn using his Z-Dream Tools uploader. What I'm going to be doing is I'm going to be trying to get like a decent interface in order to use that preview tool as an editor to be able to actually figure out what textures are going where, how to plan out what your model's doing, maybe do some basic animation and be able to export that into a game engine in the Saturn. So if I'm successful over the next month, maybe we'll have a decent 3D editor that will allow us to allow the casual homebrew game developer to try and make something in 3D without having to go through the massive headache of trying to emulate some of the 1995, 1996 tools that Sega Saturn had when Sega was developing the official tools. Because I've tried using that tool set. Eventually, I essentially had to have a virtual machine in Windows NT to get those things to run. So it's all ancient software that will probably not run on your modern computer. Okay, no more updates. Actually, let's look at the code. So let's go ahead and run this just to remind ourselves where we're at. If I recall correctly, what ended up happening was I made this little 2D environment separate from the Z-Tree Tools implementation that I'm using to test out a 2D version of this collision code. Okay, there we go. So I'm moving that one vertex, and it's what's the term here? Deforming the convex hull of the blue shape, and if I overlap, I detect a collision. If I don't, I don't. So there you go. So I believe we have a fully functional. I think these printouts are like whichever element of the 2D fields that I'm using are what order that the 2D fields are in, or which ones are in a certain order, which one's the last one to go, the first one to go, or something on the 2D convex hull drawer. But yeah, I'm still reasonably confident that this is working correctly, which, is not something I can take for granted after the first time I made this and it turned out to be completely broken. So, what do we do now? We need to project a 3D shape down into 2D and also be able to determine collision based off of that. So let's go back over the code and figure out what needs to happen in order for that to happen. So 2D tests, what's going on here? I'm defining the two fields. There's some redraw commands. There's some drawing commands. Okay, so we have, for a given field and another given field, we run separate 2D. If they're colliding, we say there's a collision. If they're not colliding, we say there's not a collision. That seems pretty simple. Oh, okay, and so we're drawing the last field connection. That's what those numbers mean. Anyways, so we're going to be moving away from this test 2D suite. I believe this part has been commented out on the main loop. Oh, that part didn't work. I gotta fix that part later. So where is what's the main loop that I'm actually running here? Main loop, because I know I'm running a main loop somewhere. Okay, there we go. So these guys, they need to go away, I believe. Oh, oops. Okay. Oh, okay. And then if I run again, we should be back in our 3D environment with a different collision code. The rough collision, as I call it. Oops. There we are. Oh, we got a third person on the stream. Someone besides Shane and myself. Hello there, mystery person. You missed all the announcements I made, but that's fine because, you know, we just got started on the programming part of the show, I guess you'd call it. Stream, whatever. Okay, so we could still place blocks. There's another block. I believe these blocks fall under the influence of gravity up to a point. There should still be a rough collision happening around here. There we go. So, okay. That's nice. So that's still working. So, I think we need to have the rough collision trigger a smooth collision. So, what does a smooth collision need to do? The smooth collision needs to take projections of each of these faces onto each of these other faces and determine mutually if any of these separating axes actually separate. Huh. I don't think this is 100% a trivial problem anymore. Let me think. Maybe I'm just getting a little bit rusty. That's probably my problem. So I remember thinking, oh, this should be super simple. This should just be doing a 3D projection. So let's go on, you know, let's go look up separating axis theorem, like for the 20th time. Just to double check to see if we actually know what we're doing here. Okay, browser there. No, wrong browser. I'm gonna have to. Oh boy, how do I switch that over? Yeah, I want to be this browser now. Nope. Sorry guys, because I got my little Twitch preview going up on the side of the screen. Maybe if I just close it out, it'll automatically switch over. There we go. And I'll just keep this thing open. Have my Twitch preview on the other screen. Okay. So I know one of these has that good drawing that we keep referring back to so that I can get my head around this problem. There we go. I like this one. So we need to do this, but in 3D. What does that mean? That means for every face, I believe we need to do this somehow until we find some sort of separating axis. So the way the separating axis theorem works, if I recall correctly, is that we're basically assuming a collision until we can prove otherwise, right? So if we can assume a collision until we prove otherwise, then what we have to do is we have to loop through every face on one shape, compare it to every face against the other shape, and try to find one separating axis, one gap that we can draw to say that they're not actually colliding. This will only work in a convex sense. Now I'm thinking in terms of what actually needs to happen per face. Like, if we have two three-dimensional shapes, let me keep that open. And I know this guy has drawings. No, that's the wrong one. Huh? What was I thinking of? Hyperplane separate. Yeah, that's separating axis. I need 3D. There we go. Let's go to this website, and this guy has some shapes that we can stare at while we think out loud. Okay, so we got these two shapes, and these two shapes, they're cubes in this case, so they're going to have 8 vertices, right? So with 8 vertices apiece, each of them having 6 faces, 8 vertices, how are we going to loop through this? I believe each face from one shape needs to compare to the entire field projected down onto the normal plane, not the normal plane, the tangential plane, which is determined by the normal of whatever face that we're comparing against. Oh, we just had 6 viewers and now we went down to 4. Did I bore you guys already with the math? Because it's not going to get any better from here. It's all math and programming. This entire multiple hour show. Okay, so we're gonna have let's say we're comparing against this face over here. Oh, we can actually see my mouse on the preview. That's beautiful. Great. So we have this face over here, and we're gonna project all these points down onto a plane tangential to that face, or I guess coplanar with that face, which is determined by its normal. And that should tell us whether or not well, that won't reveal a gap, I don't think. Because now I'm thinking this guy's going to get projected down to here, and this guy's going to be projected up to here. So this face will overlap with whatever points these guys make. So I got to build up a conception of where does the gap actually happen. So in the normal version of the code, in the 2D version, sorry, I should say, we take what? We take every normal and compare against that. So are we comparing against the normal, or are we comparing against the planar? So the normal or the tangent, that's what I got to figure out. So this projection code that he's doing, where does he define it? What is this? This PSU again. What is it? Contamination fire? No, we don't need that for background music. That is not much better than PSO. Ah, close enough. I'll work with it. Okay, so, I believe we are taking normals in order to do this, right? So yeah, we're taking a shadow onto a plane, but we need to figure out what those planes are. We got to define the planes, figure out all the planes that we're actually going to be testing against. Come on, where are you at? Oh, here's an interesting concept. Convex decomposition. We might have to implement something like that in the near future. We want to get a more strict sense of what's going on in terms of a convex compatible collision. So where, okay, there is no separating axis here. They overlap in every plane, and each plane is defined by what? The normal of the face. So how are we defining a plane based off of the normal of a 2D face? Because each one of these lines has a normal that is unique. It creates a normal to one line will create another line that is uniquely a slope and an intercept. Well, not even an intercept, just a slope. We're only really constructing a slope here, and then we can project all these points down onto the line constructed by that slope. That's not an issue. The issue is, let's go over to here. We got a 3-dimensional shape, and we have a normal coming out here. How do we define that plane? Hey, birdie. What is that? Is that a Pokemon? I can't even understand what that is. I need to zoom that now. What is that? I'm curious enough, or I'm gonna take a minute to look that up. What is that? That looks like that owl Pokemon, the one that that uses a sword or something like that. Forget the name. Oh well. Dabbing Rowlet. Why didn't I remember that? I played that game. I mean, I didn't use any of the starters. I immediately switched over to my main team. I like my Tyrannitars, my Dragonites. Okay. So, back to the problem I was talking about. We have a normal to a plane, and that's essentially a normal is a vector. It's essentially a one-dimensional-ish object in terms of it exists along a line. And if you wanted to find a plane based off of that normal, how would you do it? you can define an infinite number of planes based off of that linear object. Unless we are not defining it against that kind of normal. Oh, this guy has his own link for that. Let me see. So he's using, let's see, three-face normals from the first object, three-face normals from the second object, 9 axes from all the pairs of edges of A and edges of B. Where is he getting these numbers from? Is it the fact that they're cubes so he can reduce it down to 3 as opposed to 6? Because that doesn't apply in the general case. Because this can get computationally expensive very quickly. There we go. This is what I was looking at. We got a normal here and a normal here, but how do you draw the plane to separate the two? Let's see. Okay, this guy's saying down here. Just read it real quick. You know, sliding a stiff card in the gap. The card will be part of the separating plane if we project onto the normal of that plane. So that black arrow is the normal that we need to project on in order to find out that these guys have some sort of separation, even if it's minuscule. We have 2 vectors which lie on the plane. One vector is aligned with the edge of the blue, and the other is aligned with the edge of the yellow. The normal of that plane is simply the cross product of the 2 vectors lying on the plane. So, normal's pointing along the... So yeah, I'm reading through this and I'm trying to wrap my head around exactly what we need to check against, because this is sounding more and more expensive as I keep going. Let me try to find, you know, a good illustrated example, separating axis 3D, where it shows, okay, here's all the things that we're testing against. But we're not doing oriented bounding boxes, so we can't use that. I know I've probably read all these like 20 times. Okay. For each normal axis in body A, project the vertices of A and B along the axis. Okay, so we're not going from 3D to 2D to 1D. We're going directly from 3D to 1D. Huh. So then, how are we going to end up doing that? So we find this projection, we subtract out any depth. Well, actually, no, the dot product will do just fine because we're projecting on a line. So yeah, we're gonna take this normal, take the dot product of all these points along that normal. That will give us a coordinate from here and here. Oh, what? Sorry, I need to scroll down. Here and here, and then here and here. But we get this normal by doing what? We take the cross product of the guy heading out of the screen and the guy heading left and right to get the guy heading up and down. So cross products of each related, I guess, edge. That gets super duper expensive, like comically expensive if I think about it. Because I'm thinking about like a... let's say we had a shape, just like an arbitrary shape. Like, even imagine that table object that was just a bunch of rectangles put together. That'd be embarrassingly difficult to try and figure out. Actually, I'm just trying to think. Is there a way to reduce this problem into one dimension so that... Well, no, because you have to define that, that normal to try and check against. Unless we don't want to try and simplify the problem somehow. Huh. Because now I'm thinking, let's say we had an actually complex object. Like, let's find like even a dodecahedron is going to be a freaking headache. Dodecahedron. There we go. I can freaking spell tonight. That's not what I'm thinking. There we go. So something like this. Imagine two of these colliding. So, oh, there we go. So each one of these lines, there's, what is this? A 12-sided object, right? 1, 2, 3, 4, 5, 6. Yeah, it's basically 12 sides. Yeah, dodeca. I can count again. Okay, so each, there's going to be, how many sides, how many lines are we looking at for something like this? So that's 1, 2, 3. Here, you can help me count over here. So we got counting lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have 30. We got 30 cross product with another 30 from the other object. So we'd end up having to do 900 collision calculations to do this properly. And then after we've done that, to do those 900, we'd have to take the normals from each of those faces and do something similar. So the normals of one face and then the other. And for this, in this case, there's 12 faces per, so it's 24. So 924 calculations just to collide these two guys. That sounds super expensive compared to what I was thinking was going to happen. I mean, it's an accurate thing, but here, even this guy's doing. I'm not even sure that this is an accurate full count, because how is he determining which one of these faces is actually a real face? He's assuming they're, I guess, oriented bounding, not even oriented bounding boxes, really. They're just some sort of bounding box. So, because I know that the Sega Saturn is going to start choking on this kind of calculation if I throw it at it. If I say, okay, you need to figure out a way to do this. What I might end up doing is I might end up creating a collision box. A collision box kind of object that's attached to the actual entity. So the collision box itself will have edges and lines, but it's just going to be an actual box. So the collision box, I guess, would be generated at, like, it would be like a hitbox. I have to create a 3D hitbox. It's essentially a bounding box. But the more I think about this, the more I think I can implement this, and it would be mathematically consistent. But there's no way that it would realistically work on a Saturn without something breaking. The 2D version works great because it's relatively simple. Yeah, I mean, I didn't want to go that route. I wanted to be able to do arbitrary stuff, but after a certain point, I think I'm throwing in the towel for this one, because I'm just thinking of all the stuff the processor's going to have to do and all the other stuff I want the processor to do. But yeah, look, let's go ahead and figure out a way around this by doing this this rectangular box kind of approach. I still want to be able to do orientation because I like the idea of having slopes. So, what we might end up wanting to do, let me just break out a notepad, just do a quick. Actually, no, let's do this in Paint. Do I have a paint scene? I have a paint scene. I can display my paint, my awful paint configurations. There we go. Okay. So we're gonna have, first off, we're gonna have one box. I can freaking draw. I can draw like no one's business. There we go. We got one box, and we're gonna have another box. Let's call this the object box. I'll paint that in blue. We have what is that, purple? I don't care anymore. So we got the player in red, and we got an object in blue. Over here. There we go. So let's say I want to jump onto this guy. So the separating axis would likely be the normal face that is aligned toward the other orienting bounding box. So what I can do is I can cut my calculations in half, because what I have is I have a series of let me draw this in green. A series of normals. Come on, what are you doing? There. Oh, okay, I can move them like that. Neat. I have a series of normals. Let me draw the ones that actually don't count in. I guess. Let's put it back in purple. Real purple. There we go. Purple. And then there's going to be the forward, or there we go. Let's just do left-facing one. There's going to be a back-facing one. And the right one, that's going to be valid. So it's going to be that face. And then forward for the front face. Okay, this is a little bit hard to figure out, but you know, I'll talk through it. So I'm going to jump on top of this object. And the green arrows are the directions that are actually kind of oriented in the direction of that box. So this hitbox is going to have the center. That hitbox is going to have a center. And what I'll end up doing is I'll have a dot product a dot product along that direction. So from the center of this hitbox to the center of that hitbox, the blue one, and I'll say, well, it's probably easier if I illustrate it over here. So I jump on this guy. The center of this hitbox, the center hitbox has a vector that I'm going to construct, and I take the dot product of these three guys, or all 6 guys, whichever ones come up positive, which means they're along the same direction. Those are the ones I'm actually going to test. I don't think there's any point in me testing the opposite face of the bounding box, which I know is just rectangular prism. It's kind of unfortunate that I have to resort to a rectangular bounding box, but what I can do is I can turn objects into multiple rectangular bounding boxes, and then that will kind of help me guide a more robust collision framework where, let's say I have this big complex shape. I can give a big complex shape multiple rectangular bounding boxes, and whichever one I'm nearest, or the ones that are within my collision range, let's say, I can attempt to collide with. And the ones that are outside it, even if I'm technically within the same 3D entity that's drawn, I can attach different bounding boxes to it and just have them translate and rotate with orientation and movement. Okay. So if that's the approach I'm going to go with, that means I want to create a second entity. I want to create a bounding box. So let's try to get started on that then. So there's going to be on our collision. Let's create I guess a struct. Yeah. So this is our separate axis library, or not library, but header. Let's go over to our collision and create a new struct for a bounding box. I'm going to call it a B box. Bounding box. So it needs to track an original object's orientation. So So I'll have kind of like a... Well, I know how many points it's going to be. It's going to be 8 points. It's a freaking box. So I don't know that anymore. I'm going to have all these vertices that are defined relative to the centroid of the object. And then I'm going to have a rotation angle. So I'm going to need angle... Here's the thing. Do I need to track the angle inside the bounding box or outside the bounding box? Because presumably the angle is determined on an entity level. Let me see. My display code should have something to the effect. Or the game objects. I need to attach this to the game object. So, rotation. There we go. We have rotation from the game object. So, why don't we set up a pointer to the game object so that it has like a parent? And then the game object itself, it can be kind of like a linked list, a two-way linked list, so that the game object will have a set of bounding boxes and a number of bounding boxes attached to it that can check against collisions. And the whatchamacallit? Crap. The bounding boxes will have their parent object as the pointer to this game object that's going to be constructed for it. Yeah. Okay, I don't know why that took me so long to think that. So let's go ahead and do some mutual includes here. We have our game object header, and we're going to be adapting the collision header to do... Okay, so collision already has game object included, so all we need to do really is include what is it, collision? So it's going to be a mutual include, but I feel like it's still kosher here because we have all these if-defs preventing multiple include problems. So I think we're still okay. So game object. We have the game object, and now we're going to have our collision. We have our bounding box. So we need the collection of vertices. We need our centroid. So I'll just call it the center. This is going to be our orienting center that we're going to say, okay, this is how far we're looking, or this is the center point of that bounding box. And I think that can be calculated along at construction time. We're going to create a function to construct a bounding box. And that will take a... I guess it'll take a center point and a length, a width, and a height, and construct these vertices around that, which would be pretty straightforward. It's just adding half of each of those things to the center point. And this center point should be relative to the parent object. So basically, a normal bounding box should just be center 0 with a length, a width, and a height. Actually, to save on memory, I don't think I even need vertices. I think I just need dimensions. Let me see. Can I define an XYZ style thing? And yeah. So it'll be XYZ fixed. XYZ. And so the X will be let's put this in a comment. Length X, width Y, and depth, thickness, depth Z of bounding box. Before, let me see. Second line, and that's before rotating with parents rotation. That's going to be also an XYZ. Hey Shane, welcome back. So I realize I'm going to have to do a little bit of a compromise for this project. Looking at the mathematics behind the separating axis theorem, to do a 3D implementation require hardware that's probably a lot more powerful than the Sega Saturn is willing to be in order to maintain high resolution and enough 3D objects where I can actually care about it, and you know, good frame rate. So we're simplifying things with bounding boxes as collision objects, and I think that's perfectly fine. So I'm not trying to remake Skyrim, I'm trying to remake Daggerfall. Okay. So, so parent. Okay, well, first off, let's define it by the parent so we just know what's going on here. So game object, pointer to parent. Is that kosher? Wait, where are you? Yeah, game object is a struct. Yeah, okay. So I'll just point to the game object. The game object itself will have a position, velocity, etc., etc. We're going to add that position to the dimensions, and we're going to construct collisions based off of the game object dimensions for this bounding box. Now that I think about it, this bounding box should probably be in the oh, it is in collision. Oh, I don't know what I was thinking. Right, okay, yeah. So we're doing what we're supposed to be doing. We have a center point relative to the position of the parent, which most of the time is going to be 0. Let's put this comment up here. So there's going to be game object for the bounding box. And this is going to be center point offset from parent's position. That's going to be an XYZ fixed. And we get the dimensions, and there's going to be length, width, and depth. We're going to rotate with the parent. Rotation. Rotation. I can spell. Okay. Do we need an angle? We don't need an angle. Do we need connections? We don't need connections. What do we actually need? Oh, yeah. So, we're going to have to... Do we need to constantly construct normals? Is that what's going to have to happen? I feel like that shouldn't have to happen. Well, I mean, normals are cheap to construct if we're just going to do it at collision time, so I feel like that's fine. So really, all we need is the dimensionality of it. I really need to eventually go back and redefine what's going on with those boxes there. Let me go back and actually run the game real quick, and just to see what I think there's a readout for the position and stuff like that. Mendeven, you can't already be complaining. And no, it's Sigwin. Sigwin being stupid. Oh, like, let me, Oh, syntax error before game object. No semicolon. Lines 20 and 26. I just wanted to go back and do a quick playtest. 20, 26? There's totally semicolons there. What are you talking about? Shift F5. Is there like a space where there doesn't need to be a space? Let me see. Let's reference this guy. How do we do this struct? Same freaking way. Semicolon stuff fine as you kind of expect. Bounding box. Game object. Let's see. Line 20. Error. Syntax error before game object. That is a struct. I'm allowed to have a pointer to a struct, am I not? No semicolon at the end of struct or union. What are you talking about? I'm allowed to have a pointer to a struct. I know that. That has to be true, right? What's missing? I just named a pointer. I'm allowed to have a pointer. I've done this before, have I not? So there's int fixed, and I know I've got something else in here, like maybe game object has a pointer to something. There we go. Entity pointer to, just call it the entity, and the entity is coming from Z Dream Tools. Yeah. Giving me a semicolon means you're fixing a problem if I had ulcerative colitis. That's what I'm getting out of that. Oh, I feel so bad for the guy that just joined the stream and had to hear that. Okay. Moving on. So here is living proof that I can take a struct, have a pointer to it, end the line with a semicolon, and everything is peachy. But over here, for some reason, even after I include the freaking statement up here, I've included the header. So that should be fine. Is this here? This is still here. And for defining a struct, I don't have to repeat it in the C file, do I? No, I don't. It just needs to happen in the header. So why is it giving me the complaint that it doesn't want to get this guy? Am I defining it right? No, it's game_object. It should be fine. So why do I have error syntax on line 20? Let me see. And defend. Nope, you guys can't see that. For some reason, you guys can't see this error box anymore. Huh. And the other error is on line 26, where it says type defaults to int in declaration of bbox. Did I start the struct wrong? I don't think I did. Type def struct space open bracket. Type def struct space open bracket. I basically just copied and pasted, so it should just work, right? Or does it not work like that? Is there something wrong with what I'm doing somewhere? It's a shame that Ponut is asleep or something or awake, because I know he would have found something like here. Yeah, I feel like we're close to something like that, but I need to be able to point to stuff in a struct, because that's how linked lists work. Okay, let me just try a quick compile and run again and see if that helped. In the meantime, let's correct my spelling here. So for some reason, I feel like maybe there's like a spelling mistake somewhere that I'm missing, but I don't think that's the case. Okay. So no, it's still the same error. Error, syntax error before game object. So syntax error happened somewhere between line 20 and line 18. Doesn't make a lot of sense because this is, I've included the declaration here where the game object is a struct. And then we have our data. Okay, let me see. Line 26. I'm getting a little bit more detail. Syntax error before the close bracket. Type defaults to integer and declaration of bbox. Data definition has no type or storage class. That doesn't sound right at all. Let's It's literally just a copying and paste. Here, how about I do this? I literally copy how I do a struct here. I'll just block comment out this guy. And the only difference is I'm going to call it a different thing. I'm just going to call it a bbox. Because it's not a protected entity or anything like that. It should be free. If I try to compile, for some reason it freaking works. But there's fundamentally nothing different about what I'm doing. I mean, I gotta go back and fix that somehow. Alright, so positions. Let me see. Positions are on the scale of 1. So I feel comfortable saying that these are 1 meter boxes. So if I'm looking here, I'm at like 2.64, and over here I'm looking at 2.68. No, oh, wait, no. No, okay, I got this wrong somehow. So if I put this in the middle of the screen, I'm at basically 4-ish, and if I put this end on the middle of the screen, I'm at basically 6-ish. So these are 2 meter boxes, 2 by 2 by 2. And that'll be useful later when I have to figure out what's going on with coordinates and stuff. So for now, let's create bounding boxes that are 2. Is this guy actually going to stop himself? There we go. Good. Okay, so the soft collision's at least running. Yeah, Mendefend runs a tiny bit fast, so yeah, that 60.5 is above what it needs to be, but, you know, it's close enough. When I get the Sadiator in, I'll start doing live tests at the end of each stream just to make sure everything's running well. On real hardware, so it'll be running at real speed. Okay, so clearly this bounding box is not the issue. Is it because I want to make a game object? Okay, let's replace all the other parts with the parts I actually want to use. Whoops. Oh, that was weird. Okay, I accidentally resized stuff. I don't want to do that. Okay. I just want a pointer to a game object as a parent. So for now, let's try that and see if that compiles. I don't want to actually run Mendefend, I just need to compile it. Okay, so confirming that it runs. Ah, crap. Everything went weird. Oh, frames per? Did I not write second on that? Maybe it doesn't write everything that needs to be right. I could probably fix that real quick. Let me... It's probably something under display. Or it's not. That's weird. Where did I print that out? Collision. It's not under display. Is it under timer? It might be under timer. No, I don't think it's under timer. Maybe it's under main. I really gotta, you know, conglomerate all these guys into one thing. I'm sure there's a main loop portion of this somewhere. Frame rate, timer, gaming. Oh, I bet you it's an input because stupid. Yep, here's the printouts in freaking input as opposed to display for some freaking orientation. Or for some freaking frame rate. Something FPS. Do I run out of space? Top 15. Yeah, it's not bad. Thanks, Shane. I guess, well, I mean, 8 doesn't feel like a lot, but I guess game development is kind of a niche subject anyway, but I appreciate all 8 of you out there, even if 2 of you are probably me. 1 or 2. There we go. So, FP... Okay, so I need to move just a touch to the left. I mean, to be honest, frame rate doesn't need to be all the way over there anyway, so let's... Yeah. Yeah, so we can only print out to character 40 apparently. So let's do that, and let's move back this guy to 29. There we go. Oh, come on, man! Just don't give me trouble. I assume it's by number of live viewers. I'm up to 10, so I'm probably up on 14th place now. Welcome to the 2 new people that came in while I literally just recompiled and did nothing of importance. Okay, FPS is where it needs to be. And, there we go. Reacquainting myself with everything. So, position, rotation, and target are based off of character. Frame rate is what it is. Time is what it is. Position, velocity, I believe, are for the last object I placed. And on the top right, we have number of objects in the... What was that? Oh, thank you. Is that Japanese? Crap, that disappeared too fast and I can't read it. I'm just gonna call you Guy for lack of a name that I can actually follow, but thanks for the follow. I like how that pop-up finally worked. Yeah, there we go. Okay, so all that's working and the display actually makes sense. Now let's get back to what I was actually trying to do. This might be a problem having something to do with a mutual include, but that feels unlikely to me. Let's just do a quick replacement. Instead of entity T, we're to do game object. Huh. Maybe I can't have a parent. That might be it. But I feel like I should be able to have a parent. Or maybe I could do... Okay, I'm going to try one more time just with the parent. Itself. And if that doesn't work, what I will attempt to do... Oh, I didn't even know I had a chatbot. Huh. Was that something you were working on when I was literally not paying attention or something? Okay, well, I'll check that out after the stream. Let's try one more time to include a game object as a reference. Nope. Same freaking error. Okay, here's how I'm going to cheat. Now, I know all these game objects should be in a collection of objects, the main collection. And they all have IDs. So, why don't I just address it with the parent ID? I think the problem is... here, I'll try to point out what's going on. So, I am including... let's see what order the makefile's in, actually. I'm including ZTream tools, my main, and then a bunch of these other C files, which means the header files are each being triggered independently, or individually. So, I think what's going on is game object is being triggered, and then... Oops, whoa, crap, I just almost screwed up my makefile. That's bad. Game object's being triggered, which means the header for game object is being loaded in, and this define statement is being put into place, so that every time I include it, it doesn't get redefined. And that's fine. And then I have to include the collision. And then the collision is somehow... okay, one of two things is happening. Collision is getting triggered first, and game object doesn't exist yet. Or game object is getting triggered first, and collision doesn't exist yet, or something like that. I think it's the other way around. I think collision is getting triggered first, game object doesn't exist yet, so the struct game object doesn't exist. So I can't really do the mutual include in the header file like that when I'm defining the struct. Okay. So what I'll do is I'll just do parent ID as an integer. There we go. And game object for the bounding box. And what I'll do is I'll just call the parent ID as part of the game object's list of objects. Hopefully that'll all happen inside a function. So by the time they're called, everything's already been instantiated. That should be fine. So then I'm going to call the object and be able to call its position and angle via theta. And that will allow me to orient my bounding box. And then... from the bounding box, I believe I will have to do an actual separating axis collision. But the separating axis collision is going to be not that 933 for that dodecahedron we were talking about earlier, because we're going to simplify dodecahedron into a single rectangular prism. And then it's going to be those 15... 15 was it? Where is it? Someone listed these out. There we go. These 15 checks. 15 is a lot cheaper than 930 something or whatever, 940 whatever. Oh, whoops. I should probably switch over to my browser scene. So yeah, these 15 checks. The 3 faces on one bounding box, 3 faces on another bounding box, the normals, and then the cross product between all the edges. And that should get us what we're trying to get through. Actually, no, it's 3 normals, and the cross product of the normals. Which will get us edges, I guess, or how's this going to work? This crossed with this. Let me see. Normals. 2 oriented bounding boxes, A and B, where X, Y, Z refer to the base vectors, and 3 unique normals. So we have 3 normals along one, 3 normals along the other. Okay, so we don't even have to check to see which normal is which, because we know we know already that the normal itself is just going to be an X, a Y, or a Z, and we're going to rotate using the rotation of the game object, the parent game object. So the rotation of the parent game object will rotate the normals via a standard rotation matrix. And then we can start doing checks against these normals, and then start doing cross products between those normals. And well, if they evaluate to 0, we can just skip that check. So then we should be able to go back to what? Well, let's wipe that out first. So we got our struct here, and then that parent ID is just, we're gonna have to refer to objects by their ID. What are we looking for? We're looking for a 2D collision logic, and we're gonna see. Let me see if I have a bunch of points and I project them down using normal. I believe that should get them down onto some coordinate on that normal. So yeah, that should work. Just give me 1 second. Okay, so okay, let me turn on this chat bot like Shane's asking first before I keep going. It should be a quick fix, actually. Okay. So Shane, just a real quick aside. I think the chat bot should be doing whatever it's doing because it should be allowed now. You tell me how it's going. Anyways, so back over to the code. So I think we've got a path forward. I think if we just naively take those three-dimensional points and reduce them. Problem is, all my code was based off of 2D geometry, wasn't it? So where's my separate H and separate C? So yeah, I have a field 2D, and these vertices are 2D vertices. We got our cross product, we got our unit normals. P2, P1, and I'm assuming these P2, P1 are assumed two-dimensional. Because otherwise it'd be XYZs, wouldn't they? Oh boy, I'm gonna have to rewrite stuff in 3D just to handle this, aren't I? Okay, well, like I said, I don't really have time to customize a chat box live on air, so I guess next time we do something, there'll be a chat bot floating around somewhere. But anyway, so looks like when I constructed, I tried to compress the memory a little bit by putting everything in terms of 2 fixed points, or 2 fixed values as opposed to 3, the 3D object, and that might have been a mistake. Let me see. So I think what I'm gonna have to do is take project 1D and create a project 2D out of it. Oh yeah, go ahead, Shane. I highly encourage everyone on the stream to participate in the Sega Saturn Anniversary Game Competition. If you look right down on the Twitch, or if you're on YouTube after the fact, down in the description, one of the first links you're going to see is join the Sega Saturn 25th Anniversary Game Competition for a chance at a cash prize, which is basically all the money I'm collecting from Twitch. If you go ahead and click that link, right now you can still vote on the theme, and when the theme is decided on August 15th, there's going to be a 3-month period where you guys kind of just slap together whatever you can slap together in Joe Engine. Does not 100% necessarily have to be on theme. I just want people to submit games. Oh, there we go. There's the link right there in chat as well. And Joe Engine has a lot of really good 2D examples for you to get started on. If you're a masochist, you can try and take what XL2 has written and run with it. I feel like for a beginner, it might be easier to start with my code and run with it, even though there's not nearly as many features, but it's still technically doable. Especially after today, once I have 3D collision down, I think it'll be the fundamentals of at least like an okay basic 3D platformer or something to the effect. So what am I doing? I'm projecting 2D points onto a line, so I need to project 3D points onto a 2D plane, right? So the 2D plane will be defined by what? Or do I just need to project the 1D point down? I mean, would that be enough? let's see. I'm reducing it down to an extent, and that extent is the first times the first. Okay, so it's a simple dot product. One point, single point extent. Okay. Okay, so this is adding multiple extents, I guess. So this is building a, what's the end condition here? Oh, okay, so the extent, I forget. I should probably write in more comments here. Let me write in a description, because I already forgot what I did here. So, writes an extent that describes minimum and maximum extent of, come on, projection of 2D points onto 1D line, overlapping extents will determine collision. If you download a copy of my code, it's got a custom batch script. It's designed for Windows environment. I'm using Windows 7 64-bit every time I'm doing anything like this, because, you know, I'm basic like that. But if you take that and then you install Mednafen into your compilers, or not compilers, sorry, why did I say it? Emulators. If you just do put Joe Engine has a folder called emulators. Actually, let me see if I can show you guys what's going on over here. Let me see. I don't really have a Windows Explorer scene here that I can just show you real quick. My folder structure. Sorry. Anyway, let me just describe it. Oops. There we go. If you go into, when you download Joe Engine, there's going to be a big parent folder, and there's going to be, you know, compilers, documentation engine, emulators, and the Joe Engine, and projects and samples. If you put the whatever project you're downloading from me as a folder inside of your projects folder, and you install Mednafen as the folder Mednafen inside the emulators folder, everything should just work. Oh, okay. This one I could pronounce. Anti-aware. Thank you for the follow. If you're just joining, I don't know if you're just joining or not, but we are talking about trying to get an environment set up if you're just starting out, like Shane's about to get started out. He wants to participate in the Saturn Anniversary game competition that I'm hosting. So if you look down in the description, there's a link there. There's a link in chat right now, still up there on the preview on the side of the screen. And there's a tiny little cash prize for people that are submitting games for the 25th anniversary of the Saturn. Or at least the 25th Japanese anniversary, which I guess is the only place where the Saturn actually exists. That's where half the library is locked away. But yeah, it should be, if you have any proficiency at all in coding, it should be pretty simple to take my code and just run with it, because I include the batch scripts to just do a quick compile and run. I have everything running out of Notepad++, as you guys can see here. My Shift F5 runs a clean and compile, and run in a Mednafen script. And obviously, you can just like I said, download Mednafen and install it into as a subfolder in the emulators folder for the Joe Engine install, which comes as a zip file. So everything's super simple to install. The only problem is you have to find a quote-unquote legal way of getting the Saturn BIOS files, which, you know, come on, guys. It's the internet. You can find it. Because I don't want my channel to get taken down because I'm providing BIOS files for a 25-year-old console. Okay. But I think we still have a path forward here. My Project 1D, I just need to make a new... I need to make a new one of these. I need to make a Project 1D 3D. And just... Really, this is probably bad coding on my part. I probably should have done a better job of making this forward compatible, but whatever. Let's do Project 1D 3D. Literally the same function, except This is no longer field 2D. This is a fixed. Now, how do I get a fixed XYZ as as argument? Let me stick on this line and just look over here. That's the wrong thing to look at. There we go. Oh, it's literally that simple. Wow, okay. Sure, let's do that. So, fixed and scaled. So, the field itself is a collection of points. But how am I going to handle this? Because I need a collection of what? Is it still a collection of points? Should I point to the should I point to an entity and take those points, or should I? No, because this is the point of this exercise to take the bounding box. So I need to point to a bounding box. So do I need to include collision? Okay, collision's already included. Do I need to take a B box? Where's B box? Over here. Do I need to take a B box here and do some arithmetic to construct the normals and construct the centroid compared to the parent ID? Yeah. Shift F5 will not compile unless you specifically set up my my version of Notepad++, which is not included in my code on GitHub, and it's not included as part of Joe Engine. What it is there's a batch script called let me just name it real quick. Debug Mednifen. That should be here. Let me just drag it over. Oh crap! No, I didn't mean to click. Crap! Stop that. Okay, let me just drag it over here. Just go off on a quick tangent. So here's my debug.mednifen batch script. Super simple. Runs the clean batch script, runs the compile batch script, runs run with Mednifen batch script, and run with Mednifen batch script is a very simple, semi-plagiarized. Oh, go in the emulator directory, and then go under the Mednifen folder and run mednifen.exe. Run the queue that you just generated, and oh, here's the sound volume. I upped the volume, I think, a little bit in order to show up better on the stream. Yeah, all this is part of the GitHub install. So if you download my code off GitHub, again, links in the description. Follow me on Twitter, smash that, subscribe, we'll have a like button, whatever. Yada yada yada. You can just copy my code and run it. Hopefully what I get at the end of the day today will run, and then you'll be able to copy that version of the code. When I start working on the 3D editor, my next thing to work on for this code, for Seniriu, would be changing the ZTream Tools version to the one that's currently out there from XL2 stuff. That will be based off the 3D editor that I will be working on over the next month or so. But more on that later. But yeah, you guys can get started and, you know, hit the ground running right away if you just download Joe Engine and start playing with the examples that they have there. What am I trying to do? I'm trying to do project 1D from 3D. I'm going to call it 1D entity, and what I'm going to do is I'm going to take an entity from no, I don't want entity. I'm going to do B box, and I'm going to take a bounding box, call it B box, and just hopefully it won't get too. I'll just call it box. And then hopefully do we still include game object? Game object is still included. Perfect. Great. Fantastic. Awesome. Incredible. Amazing. We're going to take bounding box, and then we're going to use, oh, keep looking in the wrong place. We're going to take bounding box. We're going to use its parent ID to locate the position of the actual game object and its angle, and we're going to use that to define a an X and a Y and a Z. Yeah, we're going to use that to define X and Y, Z points for that bounding box. That will in turn give us some normals to work off of. So we're just gonna rotate our X and Y normals that are kind of defaulting, you know, X, Y, and Z axes. iPad. I don't get it. I don't get iPad. And then that should be, you know, a quick implementation of let's check these 15 things from this this implementation on Stack Exchange. So yeah, we're gonna be blatantly copying an algorithm from Stack Exchange. I don't care. I'm not ashamed of that. Most important part of my code is stolen from Excel too. So, you know, I'm just trying to get to the part where I can make the game. Oh my goodness, did I just lose 5 people saying that? My bad. I tell people, oh yeah, just go check out the Stack Exchange post. They're like, everyone leaves. Everyone knows Stack Exchange is toxic. Actually, what I was referencing, which I'm pretty sure no one got, would be the Sonic Colors announcer whenever you get a score rank up. That's what I was going for. I mean, next time I'll do the Halo kill streak thing. Or something like that. Okay, separating axis. B-box. We take our bounding box, and that will give us a game object to reference. What are we comparing against? We're going to take one bounding box. We're going to compare against a scaled normal. Is it a scaled normal? Yeah, that looks like a scaled normal. This is, only now it's 3D, so let's make it 3D. And then the extent, yeah, the extent is still the extent. It's what it is. And then I'm assuming down here is going to be, there we go, we've got these 2 extents. Okay, so we got this giant freaking function here. That's our separate 2D algorithm. And I'm going to do a separate 3D B-box algorithm that's just going to be a copy of this. And that'll do the job. Huh. So yeah, this is going surprisingly smoothly. What is value? What do I use value for? Okay. Ah, okay, that's just what I'm going to write into portions of extent. That makes sense. So, the bounding box. I'm not afraid of any situation where the bounding box does not have a number of points required of it. So, let us wipe that portion out. And again, I'm not afraid of any situation where I don't have enough points, where I have a single point extent. So let me wipe out that portion and just start this loop at 0. I know how many times I'm going to go up to this. I'm going to go up to this, what? How many times am I checking? I'm checking the entire box against... So the box itself, by definition, has 8 points, right? So I have to take 8 points. And this part is now redundant. Now I have to... the value is going to be the dot product. So let us take scaled X. To be honest, I'm not a fan of Chaos Zero's theme, so I think I'm going to drop it from the lineup. Sorry, guys. There, this one I prefer. Okay, so we take scaled X, multiply it with, what, the bounding boxes. Oh, we got to construct the bounding boxes, points. Do we want to do that here, or do we want to do that elsewhere? So the bounding box where am I actually going to be running this code? Project 1D. It's going to be inside of something like this. So this guy is running Project 1D where? Is it running Project 1D at all? There, it's calculating it here after a field has been constructed, scaled unit vector has been made, and extent 1 is... extent 1 has been defined. So we are assuming we're going to be in something like this already. What I need is a... Can I have an array of these guys? Can I have an array of XYZs? Let's check real quick with the SGL. Let me see if I can't go into documentation real quick and check the SGL. Documentation, how they would handle something like that. So let me see. I'm not SGL. There we go. Manual tutorial reference. Oh, don't tell me you guys can't see my dope. Oh, okay. Let me see if I can't force it to open with. Oh, this is Firefox, not Chrome. That's why it's opening. Okay. Let me add a little PDF viewer thing. Just call it Adobe. Oops. Does that work for you guys? I think that works. Wow, that looks like crap though. Why does that look like crap? Because of the wrong size? There we go. On-the-fly video editing. That's what you guys came here for. Okay. Let me, oh, whoops. Let me get the page display down there at least. There we go. Whoops. Okay, that's good to do for now. Alright, let's, this is a reference, right? This is not necessarily... Maybe we want the tutorial. SGL tutorial. So, we want to just look up real quick an example of somebody taking a fixed and making an array out of it. They have some programming examples here, not a lot. It's mostly, you know, hardware considerations, stuff like that, but they should have SGL stuff in here. Oh, there we go. Come on. This thing's full of stuff. There we go. Here's a matrix of things. Just show me some example code where I can do a matrix of things. Oh, this is just talking about quads. So yeah, Saturn uses quads because it's weird. I just want an array of XYZ. I want to be able to declare that real quick. Come on. Oh, they're talking about lighting. That's a whole thing that I'm not going to get into for any time soon. I'm going to focus on making a game first before I start trying to make it pretty like that. So yeah, they got single instances of you know, declaring an XYZ type. What do you call it? I guess I would call it a vector. I don't know what they would call it. I just want a list of these guys. I want a list of these coordinates. There has to be a way of doing that. An array of enumerated guys. Have I done this before? I feel like I've done something like this before. There's like an array of positions. Maybe I can look at my own code base and see if I've done it before. Where would that would have happened? Collision has dimension, center. Game object. Position, velocity. Oh, okay, these guys are all independently. How about Z-Dream Tools, though? Z-Dream Tools, the entities themselves should be made up of... Okay, that's the wrong one to look at. Z-Dream Tools has entities that are defined. Where are you defined? Nope. Nope. Animation stuff. Stuff we'll get into at some point. Somewhere in here is an entity that's defined. Call it like entity T or something like that. There we go. So we have position, length, and some animation. Max meshes. The entity itself should have... okay, let's look at XP data. Where's... Is that inside of SGL itself? Am I actually going to have to look inside of SGL just to see how it defines... It shouldn't have to be like that. There's... How do I find XP data? XP data. Find in all open documents. There we go. Okay, XP data is a struct that they've inherited from what? Is it SGL? A lot of defines here. Where's the includes? Oh. I guess it's already going to be included, I guess, somewhere else. Well, let's go a little bit deeper just to figure out the proper way of doing this. There is an SGL header here. SGL prototypes. There we go. I believe. Oop. Oh, we have a matrix. Huh. 4x3. And is that matrix going to be compatible with an XYZ? Can I treat each row of a matrix as an XYZ type deal, or is that not going to happen? All these Japanese comments. Yeah, I know, right? So apparently this is like lifted from the original actual SGL, which is just used as a baseline to build Joe Engine out of. But somewhere, something that has something to do with P data. There we go, P data. Point. But here's the thing. Inside of P data, if I take a point, can I address it as an XYZ? Still be good. So how do I get the points out of a P data? Because I know I did that somewhere. So I had some sort of work with that somewhere. So let's wow, I opened up all these? Oh, it looks like it's not going to be that simple. I'm gonna have to have an array of you know, I guess 8 by 3, 8 rows by 3 columns. All right, I think I just answered that question. Where were we? We were over here. We're gonna have a the box itself, and we're gonna have to construct an 8 by 3 series of points. So I'll call them corners. Fixed corners, and that's going to be 8 rows, 3 columns. So we're going to take the dot product of whatever normal that we're testing against with corners ith element, 1 for x. We're gonna first let's do corners of bounding box. Yeah. Yeah, I'm not about to Google Translate all of SGL just to figure out how to address a certain enumeration. It looks like we're just gonna have to address it the standard C way, which is just sum index, and you know what? That's just how it's gonna have to be for now. Boy. I'm already feeling tired. That's not a good sign. It's a good thing I brought caffeine with me. There we go. So the X is going to be multiplied with the first one, Y with the second one, and Z with the third one. That follows. That will give us a value, and we'll check the extent for the value. We need... Oh, do we need to initialize the extent? I feel like we do. If number of points is less than 1. Okay, let's say this doesn't trigger. Then... Oh, okay, no, we're initializing it. No, but we didn't do that yet. Okay, we gotta... Crap. We still have to initialize extent with the first single point, which means what? There we go. Well, we don't need that extra plus sign. We'll do initialize extent. So we'll do the first value, and I guess we will be skipping that first one because we'll be doing it early. Come on. There we go. This is a really weird remix of My Sweet Passion, and I'm not going to kick it off this playlist, but I am going to skip it. There we go. Everyone likes Emerald Coast. At least they should. Initialize extent. So we have our first value. So how do I address it? Oh, okay. And then extent plus 1. So we have our first single point. And then we move on from there. And we reloop through 1 through 7, which is the last 7 points in the box corners. And yeah, that part just kind of follows. So the only real part that we have to worry about is creating the corners. So, how do we rotate an object about a point? Oh, we also need the normals. We got to define normals. I feel like this is going to get expensive if we define the bounding box outside of... This feels like it's going to get expensive because every time we do the collision, we're going to re-evaluate all the corners of the bounding box. But then the alternative is that we always re-evaluate the corners of the bounding box, because anytime an object can turn, it can do that. So maybe it's better to do it this way? But then we're still repeating it for every normal, because this project 1D is getting called for every normal. So maybe I'll just store it with the bounding box, and I'll just take the memory hit just to make sure that it's actually happening, and I'll just have to update the... I just won't bother with the update for the bounding box up until it's time to do a collision check. Yeah, I have no idea what those lines say. You're going to have to provide the translations for us. Okay, so let's move this. We're gonna change up the definition of this bounding box here. We have a center, we have dimensions, but I feel like dimensions are now going to be part of the construction of the bounding box, and we're instead going to have those corners that we defined where? Where are we defining them? Crap, I lost myself already. Let's move separate all the way to the end, because that's where I'm actually actively working. Okay, so we have corners. Let us move that way over to input. Why is input open? I'm not playing with input right now. Shoot, where are you? There we go, bounding box. So dimensions will be part of the declaration. We no longer need that. Let me I'll just comment that out for now and copy that line somewhere else when I need it. Corners of the bounding box. Okay, there we go. Right. So, okay, we're gonna have a center, we're gonna have corners. But the center is an offset, and the corners themselves are also offsets, are they not? You know, I'm fine with that. I'm fine keeping it that way. So the corners themselves should be... I think they should be actively rotated. So when the object itself is rotated, we're going to check the rotation of the object and then apply it to the bounding box itself. And then the center itself is going to make it based off of that. So the corners will be an offset from the center, which is itself an offset from position. We're going to be adding those three things together in order to get the actual point. But the rotation, we're going to rotate around an assumed 0 center before we actually do anything with it. So if we take, let's say, a unit vector, or unit position. So x equals 1, y equals 0, z equals 0. We do a rotation matrix on it. We can rotate it anywhere else on that unit sphere before we actually have to do a translation. Because if we did the translation first before we did the rotation, things would mess up. And we discovered that when we were playing with the camera earlier, and we were drawing the camera translation and the camera rotation at 2 different points. Or in the wrong order, sorry. So, I think before we start the bounding box, we have to update the corners, and then we can do all these 3D projections, and then the corners themselves will be already preconditioned for that. So, where do we define that? Okay, here. Project 1, bounding box. Why can't I ever write in the right order? There we go. Yeah, fixed value. Here, let me just call it a fixed here so we don't have to... There we go. And then we'll add that comment down there. Oops. There we go. And at some point, my comments will be legible. Writes an extent that describes minimum maximum extent of the projection of 3D points. Ooh, fancy. Onto 1D line. Overlapping extents will determine collision. Yeah, that makes sense. So it's the same. It's still the separating axis theorem, except now we're going to have to do this 15 times. As opposed to just once for every... not face, but line segment, whatever. Side of a polygon. Okay, the corners are now properties of the bounding box. So, first off, this bounding box, when we're talking about that, we have to talk about a pointer to a bounding box. And then we're going to want... Ooh, this is going to be annoying. I'm going to have to do this every time. So, we're not addressing corners 0, 1. We're addressing the value of box's property corners at 0, 1. And that itself is not going to be enough because we have to do what? How do we address... How do we address these things? Here's the thing. Let's go on the internet real quick and remind ourselves how C stores 2D arrays. Oh, whoops. There we go. So let's go back and C 2D array in memory. Because we're going to have to Come on, just give me a picture. It's easier to look at a picture. So X... Why is it stored backwards? I'm like, okay, there we go, whatever. X0, X1... Oh, there we go. So you got 0, 1, 0, 2, 0, 3, 1, 0. Okay, this was what I was counting on. So then we can have 3 times I plus 1, 2, or 3. Right? Yeah, sure, yeah, sure, okay, yeah. Well, plus 0, 1, or 2. Alright, I'm okay with that. If let's trust that this is actually true. Well, it should be true. C is C. Okay. So that means, okay, B-Box. We are now taking the property of boxes corners, and we know that we're on the 0th row, so we don't have to add anything to that because we're on the first element of row 0. Oh, this shouldn't be 1, 2, 3. This should be 0, 1, 2. Well, we're about to fix that anyway, so. Yeah, so everything is a property of a struct or some other thing, so we're just going to have to iterate memory locations on top of memory locations. So this is first row X, first row Y, which is plus 1, and first row Z, which is plus 2. And then over here, we're going to have to do this similar thing. Let me just copy this over real quick first. There we go. Except now we need to add 3 times I. So we'll be going from 0, from 1 to 2, and then I equals 1, so that's 3. And 5. And then once this comes 2, it'll be 6, 7, 8, etc., etc. We'll be looping through all the memory locations, hopefully in the right order. Okay, so then project 1D B-Box should be complete, assuming that the corners themselves are updated. Maximum extents of bounding box. It's not just 3D points, it's bounding box corners onto 1D line overlapping extents. Slash will determine collision. There we go. Okay, now I can agree with that. And collision itself, what did I play around with there? There's corners. So what do we have? We have center, we have corners. The parent game object will manipulate with angles. And then the center itself will be off-center. That means, oh, the corners we need to add... Oh, hell. Okay, this is going to be fun. So the center point doesn't get affected by rotation. That's good. That means we need to add to all of these figures a center point, and okay, so we'll do. We need to go ahead of time and add in some offsets. Okay. We initialize value with dot product. Product. Okay, so we're gonna have to do 3 fix. We're gonna do x offset is equal to some stuff. Well, let's define the stuff right now. It's gonna be boxes property center part 1 added to the game object. So we're gonna have to take game objects list of objects. Where are you? Where are you? Where are you? There you are. Objects from game objects. Hopefully we have this include statement. There we go. Game objects, one of the first things. We're gonna take game objects number. Oh boy. objects number, box property, parent ID, parent. You can't even follow what I'm doing anymore. The predictive part of this thing is just broken now because I'm just going too deep in. We're gonna take the parent ID. Okay, so we're gonna take that value. We're gonna address that object, and then we need to take that property and get the X portion of what? The location, I believe? Position. Oh boy. How do we even... There's got to be an easier way to address this. Stop, create object, clone object, destroy object, is colliding. Okay, maybe is colliding is the secret here. Well, I mean, this looks like it could work. Maybe I just have to do that, and I just have to make the right address. Because I'm not trying to point to the pointer of objects. That's already there. It's in the same namespace or whatever you call it. I don't know if that's the right way of saying that, but it's already in the same scope that I'm working in, so I can just put in that number there and do dot position. It should just work. And then Y and Z offsets. So we have center plus 0 is the X part, and this is plus 1 is the Y part, and then plus 2 is the Z part. Okay. And then position is going to be Y and Z. I'd be shocked if this actually worked the first time. There's no way this is working the first time. But this will give us an X offset, a Y offset, and a Z offset, which we need to add to the box corners. But fix can add without any problem, so that should be fine. They should. Yeah, they do. Let's double check. I'm not sure of anything anymore because I keep freaking contradicting myself. Okay, when you have two fixeds. Okay, yeah, you can, if they're doing minus equal to fixed, that means they're adding fixed to fixed. So yeah, okay, I feel better about that. So let's go ahead and, oh, okay, that was a bit much. Let's just try adding the X offset. That's the reason why we, okay, calculate offsets based on entity or game object position and bounding box center offset. Okay. We got our X offset. We got Y offset and Z offset. And we're going to repeat ourselves down here. Oh, there we go. Oops, okay. And this should just work, right? Just like Todd Howard says, it just works. Here, let me take a 2-second break to go grab some water. Okay, Now I'm just thinking about how we're going to end up testing this. I'm going to end up having to take the first object and compare it against the second object. Or better yet, there should be a player bounding box. Just testing against every object that's within soft collision range, and that should be sufficient. Because I don't think I'm doing like a dynamic physics engine in this thing. This is not going to be able to handle Half-Life 2 or anything like that. I'm just going to see if the player itself, the only really dynamic object in this game besides maybe some enemies, is colliding with whatever it's colliding with. And I guess enemy AI is going to have to be similarly complex. It's not. It really isn't. Okay. So, yeah, we're just looking through all these. We have the offset, and then the bounding box, presumably, before we call this guy, which I will add into the header. There we go. And then separate 2D, we're going to need a separate 3D B-box, I guess. Hopefully we're not running into the... Hopefully we will not run into any problems with the number of functions I'm allowed to include into one file. I know that was an issue before when I tried to get a little bit overboard. Separate 3D B-box from 2 bounding boxes. Okay, so that means we get to change these from pointers to fields to pointers to bounding boxes. There we go. Just call this box 1 and box 2. You totally lost... Oh, okay, wait, was it something I said? I wasn't even paying attention to what I was saying. I can't think of the Cowboy Bebop theme song without thinking of that Bill Cosby remix of it, which is now less fun than it used to be. The Pokemon one. Well, I actually have not looked at the view count in a little bit, but 14 people. You guys are free to join in on chat and just start heckling me or whatever. It doesn't matter. Just like to see that not everyone here is a robot. Actually, Shane, I'm curious with these 14 people here. Do they rank me different? Am I still top 15 of the whatchamacallits? Oh yeah. Please follow me, or even better yet. If you guys want to start doing some game development, this Saturn game competition, which is linked down below, is a perfect opportunity to get started. If you just download Joe Engine, just play around with it. It's pretty easy to just slap together something in 2D. Top 10, ooh, the big leagues now, man. Oh, we just chased away 3 people, so never mind. Okay. Numline 1, numline... Why didn't I comment any of this? I don't know what numline is for. Oh, boy. These should be, normals. I know that much. I know these 2 need to be normals, and the 2 extents can stay put. Because they're one-dimensional, endpoints on a one-dimensional projection. But this should be XYZ. This should be XYZ. I don't need start connections. Now, okay, I remember how this worked. I don't need number of lines either, do I? Do I? No. No, I don't. I don't. This is gonna be, okay. Okay, these are gonna be projection vectors. It's gonna be normal and a scaled normal. It's gonna be, extents to test against for collision, and as soon as we fail to find a collision, we'll give up and leave the loop. Delete and render? What are you talking about? Totally lost me. Find out how many unique line segments form a convex. Okay. We're not doing that anymore. We don't need the convex hull. Actually, why did I make the convex hull for not using it? Crap. I feel like I wasted my time now. No. We're still using the convex hull, right? We're still... Are we? Yeah, I'm definitely having a do I need this kind of vibe here going on. The convex hull was for doing projecting 3D down to 2D. So I have a really nice 2D collision algorithm. But in 3D, what am I doing now? I'm directly taking dot products of three-dimensional objects down to one dimension. I'm no longer creating a convex hull, I don't think. I'm creating a shadow, which is kind of like having a automatically generated 1D convex hull based off of 3D data, in a way, if you think about it in a weird way. But that means I wasted my time on that convex hull algorithm unless someone wants to use it for a 2D game. I'll find a way to use it, but you know, I probably wasted my time here. So yeah, since I'm no longer using a 2D field, I don't need this part of that check, and that means loop through each line segment on field 1. I don't need a unit normal for... Let me see. So these normals are different. These are normals based off of 2D objects. This is taking a slope and turning it into a perpendicular vector. What I need now is a normal of the face. But the normal of the face can be calculated by assuming... I'm not taking the normal of the face anymore. I'm taking the normal of... This is a bounding box. So there's 3 cardinal unit vectors that I am then transforming using the angle taken from the game object that I've defined. So that means what? Loop through each line segment on field 1. Okay, all of this is now totally useless for what I need to do. Oh, except for that part. That part can stay. Oh boy. How am I gonna handle this? I'm gonna have to use a giant if then at the beginning of a for loop here, and this for loop is gonna go through 15 different points. Super sloppy coding. I will get the normal by... Well, let's figure that part out when we get to it. Okay, we take... Oh, do we take the normal and scale it? So... Oh, we have a unit normal function, and it's only good in 2D. I need to get a unit normal 3D. But but I'll keep it in here for now. This is gonna be a giant if. Let me see. In C, I don't have to use if. I can use select case, right? C select case. I hardly ever get to use these, but I like them. Or a switch statement. There we go. Switch case. Okay. So the switch is going to be I, and the case is going to be 0 through 14. So there we go, case 8. Well, I mean, can I just do this with numbers and not have to deal with anything? Please? There we go. Something like this. Nice and simple. So we're going to get the normals, and we're going to do a switch case. So the switch is going to be I, and the cases are going to be various. Oh boy. This already looks icky. And I don't even know if this version of C for freaking Sega Saturn is even going to be valid for what I'm trying to do here. Okay, so let's start with case... Well, that's a freaking useless comment. Oh, wow. Did I forget to show what I was working... Oh, okay. I was just copying this over into here. I keep forgetting to switch my window. No one's saying anything. I don't know why no one's saying anything. You're making fun of me for that. Okay, so let's define our case 0, and then we'll say what it is. So case 0, let's go back to the browser, like what I just left. So it's going to be the X of box 1, Y of box 1, and then Z of box 1, and then X of box 2, Y box 2, Z box 2, then cross of XX, XY, XZ, YX, YY, YZ, ZX, ZY, ZZ. That follows, right? Okay, sure, yeah, everyone gets it. Moving on. So this is going to be... get normal. So this is going to be... I'm just going to do shorthanded. So this is going to be X from 1. So that's X from box 1. This is going to be Y from box 1. It's going to be Z from box 1. Let me get the code first, and then I'll worry about repeating it. So the normal is going to be what? Okay, so I'm gonna start off with let's define our... Okay, wait, I know there's a good way of doing this. I did this earlier. I need to initialize this XYZ vector. I think I did it with like gravity or something. I remember doing something like that. There we go, gravity. So, vector. Oh, wait, is that different? Oh, and that's right. I'm doing fixed, so I have to kind of keep my mind on what fixed is. And fixed is what? 2 to the 16 bit shifting? So let's go back over to Wolfram real quick and just do a quick bit shift. So I think 1 bit shifted to the right by 16 places. I believe that's what we're doing here. Does that look right? 65, 536. I have other numbers here. I've got magic numbers in here somewhere that will tell me. Here's fixed max. So let's bit shift that right by 16, and what does that get me? 32,768. And that's going to be plus minus. Yeah, that follows. It's max int, but no, bit shifting. Okay, finally people are asking me questions. I just noticed. Well, here's the thing. It's not. We're not using it for max int. We're using for fixed, and a fixed is 2 16-bit integers duct taped together. So we have the part left of the decimal is a 16-bit integer, and it can go plus minus 32,768, and the part on the right can go from 0 to 0.99999 or something like that. But that's expressed as it's kind of like normalized against values between 0 and 2 to the 16 minus 1. So it's like 15 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Binary to decimal. Okay, so yeah, so it's that. Binary to decimal divided by 32,768, I believe. Okay, so let's just call it 32,767, 32,767 by 32,768. And that gives you 0.99. Oops, there we go. 0.99997 like 7 or something like that. But that's how fixed are handled in SGL. Actually, I think I can pull up the actual reference for what a fixed is. Fixed. No, come on. I know this is freaking defined somewhere. I'm pulling up the actual documentation here. Oh, come on! Just show me where it's actually defined. So yeah, if you want to make a fixed, you have to multiply whatever number you have by 65536, which happens to be the same as bit shifting to the right or to the left 16 times, I believe. So if I take 1 bit shifted left 16, that should get me 6556 or something like that. There we go. 65536. Yeah, there's a lot of the rest of the freaking owl to the Sega Saturn. Sometimes it gets a little stupid if you want to deal with the SGL constructs, but it's the hand you're dealt with, and it just happens to work, so we just kind of deal with it. And part of dealing with the architecture is that it does some things with fixed pretty well, and it does some things with integers pretty well, and it does absolutely nothing with floating points pretty well, so we never use them. Okay, so the point is bit shifting 16. That's what this is for. 2 fixed multiplies by a number as opposed to bit shifting. Don't know why it does that. It doesn't need to do that, but it do that. This int max is really just the most extreme value for a 16 or 32-bit integer that happens to be the same as the fixed. Basically, the biggest fixed thing, because fixed is basically stored in memory, identical to a 32-bit integer, which is just 2 16-bit integers duct taped together. What was I doing? I totally lost track of what I was thinking about. Oh, it's past midnight. That's nice. Might have to break out that Red Bull at some point. I have to calculate normal based off of x1, and that x1 needs to have what? We need oh yeah, we need to initialize a fix. That's where I came to start with. So that fixed, I think I was stealing from here, but I don't like to fixed. It's slow. And I'm not even sure if vector is the right way of doing it, but we'll roll with it. Actually, I know that test2D has field verts is fixed, right? Just look at collision real quick and just look at the crap. No, go back down. No, separate has field2D. Field2D has verts. Verts are fixed. That means I can deal with fixed verts like this. There we go. Bit shifted to the left 16. That's exactly what I was looking for. I'll just do this and put a 1 there. But it's not treating them with the enumeration that I expect. So I'll do that. I'll do that 1 line at a time just to be safe, you know. Okay. There is a point to all this, all these distractions, and that is me defining normal. Let's just call it 0, 0, 0 for now, because 0 and fixed and 0 in integers is the same thing. Right? And then scaled, something similar. And then in the case of x1, I'm going to have normal. Boy, do I have to do this. Oh no, I can just do it like x. Okay. Normal x. Oh, why would I do that? Is equal to 0. No, this is equal to 1 bit shifted left by 16. Right? Right. There we go. Indent. And then y and z are just going to be 0. That is our unit vector. And now we get to do some arithmetic. Now here's a fun question. How do I do matrix operation? I know SGL has matrix operations. I know it, I know it, matrix. Matrix. Man, I know you have matrix multiplication somewhere. Come on, man. Don't hold out on me. Wow, they got a lot of matrix operations here. I just want to multiply a specific matrix by current matrix. Can I multiply a matrix by a whatchamacallit? An array, or not an array, vector. Oh, this is interesting. Oh, sorry guys, I was looking at the documentation, wasn't even showing you. Matrices in SGL are stored as 4-row, 3-column matrices. However, when performing mathematical operations, the matrices blah 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 4 by 4. Yeah, okay. But I'm working with 3 by 3s. What's the fourth for? What does the fourth do? I have no idea what the fourth one is for. This must be something specific to light stuff. All right. Yeah, yeah. This is not what I'm trying to use it for. That's it. I'm just trying to do normal matrix operations, 3D matrix operations for X, Y, Z. I just got to do it manually. I'm just gonna do it. So yeah, here's a nice little. This is what I want to do. Axis vector, axis vector, axis vector. Okay. But these all operate on matrices, and I'm not storing things as matrices. I'm storing it as a. Okay, I'm gonna have to do this manually. Okay. Huh. But here's the thing. I've got 2 bounding boxes, and those 2 bounding boxes both have orientations. I should pre-compute those before I start sweeping through all these different things. I think about it. The RGBA stuff is probably just to do with lighting things, so I'm sure I'm going to be using that stuff later on when I learn how to do lighting. But right now, I'm just doing normal rotation manipulation. Okay, I'm starting to get the feeling that I need to be storing like all 15 matrices, or not matrices, all 15 normal. Actually, I don't even need the switch case. What I'm going to do is I'm going to store all these normals as as a giant array. It's going to be a fixed array of... what? We're going to have 15 by 3 normals. And then scaled is going to be something similar. And then we're going to have to calculate all the normals. That'll be fun. What was I doing to scale the normal? I remember doing something. Okay, let's open unit normal. Where is that? An extreme convex hull, max angle, convex hull. All that stuff is kind of old hat now. Unit normal. There we go. What was I doing to scale? I was I was dividing. Whoops. So instead of dividing, why can't I multiply by a small number then? Because multiplying is cheaper than division, is it not? One divided by 1.5. Okay, what's okay. Whoops. Okay, wrong scene. There we go. But not the documentation, Wolfram. So 1 divided by 1.5 is 2/3, I guess. Oops. Okay. Okay. And then we're going to take that 1 divided by 1.5 and multiply by what? 2 to the 16? So instead of dividing by, what was that? 98,304, I could save time by multiplying by 43,690. Yeah, let's do 43,690. And that will be cheaper on the CPU. Because multiplication is a lot cheaper than division. So I'm already having to divide out over there. No, it definitely will not. This is the Sega Saturn. Remember, this is 25-year-old technology. Division and multiple. This isn't just simple division. This is a function determining what kind of operation I'm doing. So the fixed require tool chain. The tool chain is essentially SGL. That's the tool chain. It's the Sega graphics library. I mean, I'm not sure what else to say. Like, Sega graphics library is kind of like the backbone of what I'm using right now until we come up with something better. Technically, yeah. But again, if you look at the function I'm highlighting here, it's not just like I'm using, you know, a forward slash to denote that I'm dividing. I'm taking a data type called fixed that requires its own special function called division in order to divide. And the division unit on the Sega Saturn is not quite as good as the multiplication unit. So it's not like the compiler itself will optimize for me. That's not the issue here. It's a specific function that I know is slower than the alternative, which is the SL mult FX, which is multiplication of fixed. So, actually, I could probably speed up this line by dividing 1 over magnitude. Calling it inverse magnitude. Fixed. Or reciprocal magnitude is equal to SL div f. Oh crap. Div fx mag 1. This can now be sl mul fx. Did I just press insert? Reciprocal mag minus dy, and then mag dx, and then over here I'll have 43,690 multiplied through by whatever unit I'm doing. 43,690. So in this case, 1 divided by 1.5 is equal to 2/3, which is basically the equivalent of 43,690.7-ish, whatever. So, I mean, I'm not familiar with how familiar you are with the Saturn. I don't know if are you going through SGL to find these things? Because remember, this isn't like a standard processor. Yeah, this is the processor on the Saturn is not like an x86 or an x64 type processor that you're thinking of. Yeah, it's a library that's designed to go on a piece of hardware that is not a standard piece of hardware. It's not built the same way as like an Intel processor for a modern computer. This is a 25-year-old console, a video game console. It's got specialized hardware for this, so it's got special parts of its processors per division. They're still slow, and it's still division of a specific numerical type that isn't even built properly. Like, it's not built in a way that kind of makes sense. Like this fixed. You seeing I'm having to do all this stupid arithmetic just to convert basic fractions into stuff because floating points are super slow. And then everything after the decimal, or everything to the left of the decimal, is still stored in kind of a weird way in that it's the same number, but you just have to bit shift it. So yeah, it's the GCC compiler would never ever know to do this because, you know, how many times has the SH2 ever come up to do the stuff like this? SH2 was basically only ever used on the Saturn, to my knowledge, and maybe some select stuff. And it's built in the way that it's built. So this is actually a common programming technique for Saturn people, is to divide out something ahead of time and then multiply it through. So that's what this is. So yeah. So there's a little bit of an additional challenge to working on the Saturn because of things like this, where you don't have all the comforts of more modern architecture. You can't depend on floating points, and you can't depend on like an arbitrary amount of memory. You're kind of restricted to what you got. What is this music? What is going on? Okay, it's PSO. It's just PSO Episode 3, which I didn't play. It's fine. Okay, I just fixed up the unit vector, which probably didn't even need to be fixed up, but whatever. Scale, let me keep this. Yeah, the scaling doesn't really matter, because apparently I approximated square root of 2 as half, or 1.5 or something like that, so that's plenty. I don't need to project 1D, I need this guy, right? So the normals, and we got scaleds. Okay, so we got to construct construct normals. So then this itself is probably just going to end up being a for loop based off of normals. Okay, whatever. Yeah, I can probably just end up defining that now, just to get it quick and already over with. Oh, I could put that inside of this loop and save myself a little bit of real estate. So then, scaled I1 is going to be equal to normal. Okay, well, it's going to be equal to SL mult. SL mul is plus times normal. Normal I1. And we do the same for 2 and 3. There we go. And then now we have our scale just in case something bad happens with the projection. Still got to construct the normals. Huh. Okay, so we have to construct the normals, and then we got to loop through and rotate them. So, rotate. No, because we have to rotate ahead of time. Crap. We got to figure out how this is going to happen. I got to define the first 3 normals, then rotate all 3. The second 3 normals, rotate all 3. Okay, at least I've got decent background music now. Okay, let's rotate the normals. Normal 0 0. Did I screw up the indices again? Of course I did. 0 1 2. Normal 0 0 is equal to 1 bit shifted 16. Zero, 1 2, and then we're gonna have okay. It's gonna be 1 1 1 2 2 2. Construct base normals. I'm going to take this 0, move it over here, and this is now the Z, so we have our X for the first 3, Y for the second 3, Z for the third 3 for the normals. Define the same thing for the normals of the second object. Oh boy, this is just an ugly mess, isn't it? Ooh, 3 3 3 4 4 4 5 5 5. Let's try to label this. So X1, Y1, Z1, X2, Y2, Z2. Okay, here's our base normals. Now we gotta rotate them. So we gotta figure out the rotation matrix for... Oh boy. Well, let's go back on the internet and look up rotation matrices. Now I get to include the, I need a full rotation matrix, let me see. Oh boy. You have an explicit version of that? Oh boy. Okay, there's got to be a cleaner way of doing this. Come on, just... There we go. Okay, so this... Let's see if I can't zoom in a little bit. Okay, there. So, we're gonna have... let's see, 3 main angles. Do we have... rotations around X, rotations around Y, rotations around Z. So... Oh, this is gonna be super ugly. I'm gonna have to define a rotation matrix for both of these guys and then apply it. Oh boy. I'm gonna keep this on the right hand side for right now, just for my reference. Whoops. What happened there? Okay, there we go. This should probably get broken off into its own thing, its own function. Probably have like a separate function for it, but right now I'm just gonna try and get it to work, so I have to write it first and then I can break it off later. So let's create rotation matrices. Oh boy. Construct rotations. Let's get rotation angles. This will be angle. Oops, angle is equal to, okay, this is gonna be angle R x1 is equal to what? We have bounding boxes. Bounding boxes have what? I had to do this earlier. There we go. Project 1 dB box. The bounding boxes have parent ID. Let's see. Position X. Okay. We take the bounding box, we take the parent ID, we get the object, and then we find not position, but rotation. Where are you? Where are you at? Not that one. Not that one. Game object. There we go. Call it theta. Theta X, theta Y, theta Z. Alright, let's do that. Where do I put you? I was just there. There we are. Because I'm going to need cosines and sines of everybody. That's going to get ugly. Ooh, so many multiplications of fixeds. That's gonna get nasty very quick. Oh boy, okay. At this point, I'm just trying to find a way to condense just the notation. Like, I'm taking a small memory hit just to condense the notation so that it's not hideous to look at. So I can actually look at it later. We get rotation angles for the first guy and for the second guy. But it's not just box. It's got to be box 1 and then box 2. That means the player would probably have to be object 0 in order for this code to function well. I'm starting to think that this this stream might end with me saying, okay, we're at a halfway point, and then next time I'll actually finish it. Because this is starting to get a little bit not unfeasible, but scope is starting to creep on this specific thing. Okay, so we got our rotation angles for box 1, rotation angles for box 2. Okay, now we got to build rotation matrix for box 1. Okay, so I'm going to call that... Oh, let's declare it up ahead. Rotation matrices. Matrix SC. There we go. It's going to be fixed. They're going to be... I'm going to call that R1. It's got to be a 3x3. There's going to be R2. That way we're going to try and condense it as much as we can in terms of just readability. This doesn't need to be here anymore. Okay, this song's a bit much, and I'm going to drop it from the lineup. Okay, this is going to put me to sleep. Let's get something a little bit... No, not that one. No, it's not like Adventures. There we go. Gotta wake myself up a little bit. Rotation matrix for box 1. Oh my goodness. Already slipping over. So, so phi is for X. Theta is for Y. Psi is for Z. So we're gonna have... gotta calculate. Okay, so we're gonna have R1 0 0. That's gonna be the XX contribution of that specific matrix. We're gonna have SL cosine. Is it SL cosine? Or is it Joe? Does Joe engine have its own cosine? Okay. Back to the documentation. Let's just start cosine. No, just give me the freaking fixed SL cos. That's what I figured. Takes in an angle. All right, good. So we have angles. Let's give it angles. So SL cos for theta should be for Y, so that's going to be RY1. We got to multiply them together, so it's going to be SL mul FX. This with psi would be Z. And that was the clean and easy one. Oh boy. More math. Okay. So for first row, second column, we have a minus cosine of the x component sine of the z component. And then we have to add in, do a second line for that one. It's going to be a multiplication of three things, so I'm going to have to nest these guys. Oof. Okay. So sine of first, sine of... Okay, sine of the x component, sine of the y component, cosine of the z component. I'm wondering if there's an easy way to combine these somehow. I know there's like different properties of sines and cosines, like trig identities that I can use. Maybe that'll kind of make things a little bit easier, because instead of copying this whole freaking thing, maybe I can use a trig identity to try and compress some of these, like, because 3 multiplications in a row is just asking for trouble, I feel like. Let's try doing trig... Oh, no. Sine, cosine, identities. And maybe there's a way to cheaply combine a product of sine and cosine as... Yeah, I was looking for something like this, but I'm going to have to specifically find cases where this is happening, and I don't think that's happening anywhere. I mean, cases where this doesn't actually happen. Not in that matrix. It's really hoping for a product of... Oh my goodness. Here's the thing. This... Oh, there we go. This is probably what I need. So we have cosine alpha cosine beta is equal to cosine alpha plus beta plus cosine alpha minus beta divided by 2. And that's just multiplying by 0.5. And 0.5 can be approximated as what? 0.5. 32,768. This might actually work for me. Okay, let's try it for the first one. It was cosine of ry1 times cosine of ry2. Or rz1, sorry. ry1 times cosine of rz1. So that's our alpha and the beta. Surprised people are still hanging around for this. At this point, I've just delved straight back into math. Okay. We have the alpha, we got the beta, so that means, yeah, R1 or RY1 plus RZ1, and then cosine of RY1 minus RZ1 divided by 2, or multiplied by this number. Let me just keep that on hand right now. So let's try that. So we're gonna have 32768 times the sum of 2 cosines, which is feasible. Okay. Let's cosine ry1 plus rz1 and then cosine ry1 minus rz1. There we go, and that's the first thing. Second one, we need a cosine of rx1 times a sine of rz1. So if we go back to our identities here, Well, I mean, you know, multiplication is, you know, symmetric. So sine times cosine, same as cosine times sine. So that means we can take the... Okay, so it's cosine rx1 times sine rz1. So we take alpha as rz1 and cosine as rx1. And we're going to replace it with this sine of the sum plus sine of the difference times half. Okay. It's not too different from what we had over here. Okay, so let's take that as a negative. Can I put a negative sign in front of a fixed? Is that how that works? Yeah. Okay. Okay, and instead of... Okay, so the sine is rz1, so alpha is rz1, and cosine is rx1 plus... Okay, that's plus... Beta is rx1, and then plus the difference. So let's take... Oh, this is a sine, not a cosine. Then we add the difference. There's a much simpler way of figuring this out. I can let Wolfram do the work for me. Why am I doing the work myself? I should be a lot lazier than this. What is going on? Okay, back to the browser. So we're taking this term over here. So let's do sine of x times sine of y times cosine of z. Go into Wolfram and see what it simplifies it to. Sine x times sine y times cosine z. Come on, simplify. Oh, wow. See, that's nice and convenient. We have a quarter of a bunch of these different terms. And that's actually a really nice, fast, quick thing to do. So now I just need, since I have 1/4 in the front, I need 1/4 times 2 to the 16. 16,384. Okay, so let's do that. So let's add 16,384 to the sum of those four cosines. I'm wondering how much error I'm introducing by adding all these fixed together. Probably not a negligible amount, but you know, we'll see where this goes. Okay, so cosine rx1 minus... Okay, I'm going to write this kind of condensed so that I can actually fit everything in a reasonable space. rz1. But everything's cosines because it's... Yeah, okay. Thank God for Wolfram. X plus y minus z. Okay. Okay, and then what's the last one? X minus y plus z. Looks like every freaking combination. Then x plus y plus z. It's so incredibly convenient. I don't know why it's never expressed like that. Wow, okay. Let's do the next one. Wow, that was... I like when I don't have to do too much of the thinking myself. Where's my browser scene? There we go. Browser. What's the next one? We got two sines, and then cosine, sine, cosine, and then cosine x, sine y, cosine z. So they do cosine x, sine y, cosine z. Oh, there we go. It's basically the same thing except with sines. Oh, let me double check to make sure I didn't get any addition and subtraction errors on cosines. Oh, I did. I forgot this minus sign over here and this minus sign over here. Oh, who did that? Oh, Rydor. Welcome to the stream. Thanks for coming by and following. Despite the fact that this is probably the most boring part of the stream, is where I just struggle with math. So, okay, we have cosine x minus y minus z minus cosine x plus y minus z plus cosine x minus y plus z minus cosine x plus y plus z. Okay. I'm feeling a little bit more comfortable about that now. Next. So we have this product of sines. We already know what that's going to look like. We're just going to sub that in. Wait, do we know what that's going to look like? Did I screw up that cosine minus a cosine? No, sine and cosine. Okay, yeah. Okay, I didn't do that wrong. Good thing. Okay. So, cosine, sine, cosine, according to this. Cosine, sine, cosine. That's the hard part. He's going to have, you know, that quarter in front, and then minus, plus, minus, plus. Same kind of thing. So, let's copy that last line and make the necessary adjustments. Come on. Okay, this is the Z contribution. Oh, another follower. Mish. Oh, goodness, you're making this difficult. Mish Tizk. Crap. Sorry about that. You need to disappear too fast for me to figure out how to pronounce it. But thank you for following. Where are you people coming from? It's 1 a.m. for me. I'm starting to lose some steam here. I'm just going mildly insane trying to follow what I'm trying to do here. Okay, let's fix the first part. So we have the first component was sine of the x component times sine of the z component. So the sine times the sine xz is cosine x component minus z component. And all this is going to be divided by 2. That's what this multiplication factor in front is, because we're doing the fixed algebra. And then sine times a sine turns into a cosine minus a cosine. So we can avoid all this unnecessary multiplication. And then the addition comes out to what? Cosine of alpha plus beta, which is rx1 plus rz1. Alright. And then we just figured out what that second portion of that term is, which is cosine of the x times sine of the y times cosine of the z. X, sine of y, cosine z. And that's going to be 1/4. That's this portion over here. Times minus sine. Yeah, this math is starting to get annoying for me at this hour, and I have a freaking piece of paper saying I have a degree in this stuff. Wow, that is an annoying piece of music that slightly woke me up, I guess. Good job, you're not going removed off the playlist. Close enough. A lot of Sonic Adventure stuff coming up tonight. Sonic Heroes. Sonic Adventure 2. Good enough. Okay, yeah. So, what's going on is freaking, yeah, I'm just defining a rotation matrix. So I'm just copying over the rotation matrix from Wikipedia, but I don't want to do all that multiplication because that's not great for computation time, so I'm turning everything into addition. So I'm using the trig identities. Or not trig identities, what do you call them? No, they are trig identities, because, you know, it's sines and cosines. But feels weird saying that. Probably because it's late and I'm getting tired. I think I'm going to calculate these rotation matrices, make sure there's no compilation errors, and then maybe head to bed. RX1, RZ1. Fixed multiplication, that is a good question. To be honest, I'm not the guy to ask about this. I've only been at Sega Saturn programming for about half a year now, and I still can't remember a lot of this stuff. It is significantly more expensive, at least 4 times more expensive than addition. Remember, fixed are not quite a real data type. They're 2 integers duct taped together, but both halves of the integers are treated slightly differently. So when you do the multiplication, you have to split them up, multiply 2 different things, add the remainder. It gets ugly, and it gets even uglier by almost, I think, like an order of magnitude when you do division. The way you do division in the Saturn is you literally set up the divisor. Like if you do like x divided by y, you set up the divisor by dividing 1 divided by y at the very beginning, as soon as you can, and you send it off to the division processing unit. And then you go and you do other stuff, and like 30 or 40 operations later, you kind of hope that the division operator is done, and you grab that result after you've done everything else. So you literally have to kill time while waiting for division because of how expensive it is. I mean, the Saturn is great in that you can do parallel processing, where you can start a division operation and do some other stuff. But you still have to wait because it's so slow. So whenever I can, you turn division into multiplication, and in this case, because there's so much freaking multiplication, I want to turn multiplication into addition. Because first off, I'm scared of errors propagating through lots of multiplication of small numbers. I trust addition more. And second, I'm pretty sure this addition is going to be faster, because the cosines and sines are lookup tables. That's like lightning quick. And then addition is just, I think addition is just straight addition, because the way that the fixed is defined. Yeah, that's the thing. When you're working on modern architecture, you have a lot of luxuries like that. You can have an arbitrary amount of memory. You can assume that the processor is really good. You don't have to work within too many restrictions. You don't have to worry about the CD rewrite speed, so you don't have to get stuck trying to load something, and you don't have enough time to load it before you try to run it. So it's it's like I keep saying, when you program on the Saturn, you adopt certain difficulties inherently that have to do with just hardware speed for a 25-year-old piece of hardware. My goodness, I gotta really go through this playlist and try to get something resembling an order in here or something like that. Totally lost track what I was doing. Crap. Okay. We're doing the Z component of the rotation matrix for the X row. And we have sine of the X component times sine of the Z component, which means Rx minus RZ minus cosine Rx plus RZ. Okay, so that part checks out. And now, on the second portion of that, we have cosine of the X times sine of the Y times cosine of the Z, meaning we're using Wolfram for this one. So the first unit is minus sine X minus Y minus Z plus sine X plus Y minus Z. Oh, the order is the same. That's nice. Just have to flip some signs. Minus sine. How convenient this all turned out to be. X minus Y plus Z plus sine X plus Y plus Z. Okay, first row is done. And then we're just going to copy this to do it for the matrix number 2, and that'll be peachy. Row 2. Y component. This is not too different from what happened up here with the cosines and the sines. So I can copy a portion of 0, 1 for the negative portion of 0, 1 and just change the Z component. No, not the Z component. Change the X component to a Y component. Okay. That follows. Let's do that. Okay. So, the first part of this guy would be this. So it should just be the same thing. We take R1, row 1, column 0. And then we have... Why is it Z plus X1? Why do I have that order? That's a weird order. Now I'm starting to worry about the order I'm doing some stuff in. Oh, it's because of the sine and the cosine, because I'm taking that trig identity from that page. Because it's cosine times sine, so I reversed it to get sine times cosine, so I can copy the trig identity, which is sine of the sum plus sine of the difference. Where's the difference? Don't tell me I already screwed this up. Oh crap. Oh, I hate. Dang it. Okay. Back. Yeah, I think this needs to be negative. Let me double check. So that component is cosine of the x component times sine of the z component. So that'd be like sine of z plus x plus sine of z minus x. Is that what I just did? Z minus... Okay. Yeah, that follows. And then in this case, I'm just going from cosine of the x component to cosine of the y component. So this part, I can just switch this to y. Why is this? There we go. And then that element's done. R1, 1, 1. Okay, let's look at this freaking mess. Okay, product of cosines. That's pretty simple. And then sine, sine, sine. I feel like this shouldn't be too painful. So cosines of x and z. Actually, this is just the first element. Oh, I need to have semicolons here, don't I? Yeah, I gotta make sure I have semicolons. This is the first element. Only instead of the y and z component, I'm doing the y. Okay, instead of the y and z component, I'm doing the x and z component. So I just replace the y parts with the x parts. Really hope that's how that's going to work out. All right. And then we need to add the second portion, which is sine of x times plus sine of y times sine of z. It's going to be a quarter of 4 things added together. We just need to know what those 4 things are. Okay, so what do we have? We have quarter in the front, which is, you know, expected. That's what we thought was going to happen. Minus sine x minus y minus z plus sine x plus y minus z plus sine x minus y plus z minus sine x plus y plus z. Okay, there we go. Let us go into the notepad and try to track what just happened. X minus y minus z. Actually, this order looks pretty familiar. Plus x plus y minus z. Okay, there we go. Here's a sign flip. This is a plus now. X minus y plus z, and then minus. It's because we switched one of the cosines to a sine or something like that. X plus y plus z. And then that quarter is already in the front. And this portion of the line is done, so we're most of the way done already. R1, 1, 2 is equal to some new fresh hell. Minus sine times oh boy. Is this a repetition of something else? Is this a repetition of... This looks like a repetition of the second element with some things reversed. So let me take that element again, copy it over, and then we'll flip around what needs to be flipped around. So we have sine of the x times cosine of the z. So that's sine of x plus z. And then plus sine of x minus z. So we just kind of flipped one thing around. That's it. There's a minus sign in front still, so that's staying. And then plus cosine, sine, sine. So what's cosine, sine, sine? Oh, let me just double check. That's cosine of the x times sine of y, sine of z. So that's a quarter. And then minus cosine x minus y minus z plus cosine x plus y minus z plus cosine x minus y plus z minus cosine x plus y plus z. That was almost a little too easy. That shouldn't have been so similar. Cosine, sine, sine. Because I don't think I changed anything for that line from the first line up there. So sine, sine, cosine, as opposed to cosine, sine, sine. Those two can't be identical. So let's find out. Yeah, they are different. So something had to have changed. But if I look over into these guys, cosine. Oh, I flipped a sign or something like that. Yeah, I flipped this sign over here. Okay, I just didn't notice that because I'm freaking tired. I'm not trying to make this another one of those that like that 7-hour stream that happened that one time. I'm trying to avoid that. So I think we're almost done with the rotation matrix. So I'm gonna get through this rotation matrix, and I think I'm gonna call it quits. And then next week we'll just push the schedule back and keep working on this. R1, 2. Whoa! Don't do that. 0 is equal to. Let's see. Oh, that's simple. Sine of the y component. Oh. Minus SL sine RY1. There we go. Things are looking up Millhouse. And then we had got sine of the x times cosine of the y. So alpha in this case would be the x and beta would be the y. It'll be 1/2 times the sum of sines, which we've done before on R10. It's going to be sine of the x, cosine of the y, alpha is x, cosine, or beta is y. So it's going to be x, y, and then x minus y. Okay, so I know we did something very similar earlier. Okay, then the last bit is 2 cosines. Cosine of x and y. So it's sum of cosines, difference of cosines. We've done that. R1, 2, 2 equal. Only instead of y and z, it should be x and y. Okay, there we go. Let me keep the order if I can help it. And then I'm going to do a Okay. So we're done with actually writing out the rotation matrices. We'll just do a quick find replace and then fix it in post. To find a 1 and replace it with a 2 inside the selection. And then we just got to fix the parts that didn't need to be fixed. Okay, let's go ahead and call that in. Let's see if this will compile. Oh boy. Wow, things are breaking in ways that they shouldn't even be breaking. Storage class specified parameter frame num in main C44. What? Oh, it's got a problem with me including what I'm guessing is either separate or collision, probably collision or game object or one of those guys. Oh boy. Something broke in a weird way and I gotta figure out why it is. Oh, did I not include this as a declaration inside of the header? Maybe that's it. Yeah, you have to do that. Let's try that again. Okay. One more time. Crap, I can't show you guys the debug. Maybe the mend defense scene? Nope. Okay. Well, you just got to take my word for it right now. It's, Shadow Declaration is here. "61, 76, and 89 have tokens. There's got to be some reason why this is breaking in a way that it shouldn't be breaking. Of course, I've done so much progress here that I probably... Okay, where did I add something here? Collision? Is rough collide, calc rough radius. I don't think I added anything new in collision to cause that to happen. Just added a struct. Why are you broken? Okay, we gotta figure out what's going on here. Why are things broken? What did I add? I added B-box. I added this 1D projection. I added separating axis for 3D. I mean, I didn't even finish that. So what am I missing? Did I break something in main and then just forget about it? Let's see. I'm including test 2D, collision, game object, collision. Just think, if I'm including game object, collision's already included. So maybe if I get rid of that. That didn't help. In function project 1D B box. But where is that? Wait. Why is it saying that's in there? It's saying main.c in function project 1D B box. There shouldn't be any calls from one to the other. Let me look for B box. It's not in main. And then project 1D B box doesn't have any calls to main that I know of. Yeah, it just does its thing. It's a basic function. It shouldn't even be coming up. Something weird is happening where it's there's oh, you know what? I think we finally did it. I think I finally came up with one too many functions for a given file. I think that's what this error is. Let me comment out the extra functions that I added. Where did I add them? Separate? Let me comment out the additional functions that were defined today. And then project 2D points on B-box. Okay. We are getting rid of B-box and we're getting separate 3D B-box. We're seeing if that's going to do it. I think it's because we have one too many functions. We got to break some stuff off. We got to split separate into separate 2D and separate 3D. Come on, just freaking work with me here. Keeps giving me Sigwin errors, and I don't know if that's a symptom of... Oh, nope. It's exactly what I thought it was. It's another one of those stupid freaking quirks with working with old hardware. You're not even allowed to define too many functions in a given C or header file, because otherwise it just won't compile. So you got to keep splitting things off into more and more files. But no, things are still running. So effectively, nothing has really changed. I've just laid down the groundwork for what needs to happen for 3D collision to happen past this point. So this is the rough collision happening right now, where it's like, okay, we're in a collision radius where we actually need to start carrying. So I just have it programmed to just flag it colliding by default when it reaches this point where they're close enough to say we need to actually take a closer look. But after that, we're going to finish implementing that separating axis theorem and have these guys actually try to touch, or almost touch, and stop each other just before they touch. And that will be the true collision that happens between objects. But that kind of collision physics will only be valid for actual moving characters. So basically, player and any enemies he encounters, or any NPCs. But I'm planning on limiting the number of NPCs anyway, so it's probably just mostly going to be enemies. At least in the environment where collisions matter. So for now, I think I'm gonna throw in the towel because I'm definitely way too tired to try and keep going in the direction I'm going. We have the direction we need to go and set up, and I will continue next week finishing up this separating axis collision like I keep promising to, and I keep almost getting closer to. I do want to just reiterate the announcement from earlier, since now we have more people on. We do have that Sega Saturn 25th anniversary game competition. There is a small cash prize that I'm providing via my Twitch subscriptions. If you want to increase the cash prize for people participating, you can use your Amazon Prime subscription to subscribe to me, and that will any money I get toward this Twitch channel goes directly into Saturn projects. So either right now, all the money's going to go into the cash prize for the Sega 25th anniversary game competition. Once that's over, I'm going to try and pull it to start buying art assets or to start funding other projects besides myself, depending on what I think would be the best use of the money and how close someone is to creating like a real game. My number one goal really is to try and get more games out on the Saturn. I would like to ask everyone to follow me on Twitter so that you can actually keep up with the updates when I'm going to be streaming, if I'm doing something besides a standard stream. And of course, follow me on Twitch and subscribe on YouTube so if you follow on Twitch, you're already seeing everything live as it goes. So YouTube is basically just my archive. But for now, I think, like I said, throwing in the towel, going to bed, and we're going to pick this up next Friday, same time, same place. So this channel on Twitch, 10 p.m. Eastern Time, which is 2 Universal Coordinate Time. Yeah. Oh, thanks, man. To be honest, I'm super bad with names, so I feel like I should already know a lot of you, because I don't know if you're already on the Sega Extreme forums, if you're already on the Sega Extreme Discord. Thing is, I mostly talk to like the main handful of guys that are hanging out in general on the Discord, and everyone else's name, like, I didn't even know until like about a month ago that VBT was such a huge deal, because I didn't know anything that he produced. But yeah, if I should know you and I don't, I'm sorry, but I'm tired and I'm bad at names. But thank you for your thanks, and like I said, I'd appreciate if, yeah, I'd appreciate that if you have even a passing familiarity with any sort of programming, that you give it a shot. I think everyone should just try to make something on the Saturn real quick. Joe Engine makes it super simple. It already has it has a Sonic game basic setup, where you can run around and jump, and I think you can collect rings as well, I don't know. And it has a basic spaceship scrolling shooter game. And those are both excellent frameworks to get started, and if you want to try and slap something together, use your artistic skills to make something for the game competition, I want as many people to submit an ISO by November as possible. You can see the link down in the description. Let me copy the link for you in chat so you guys can click on it. I think it would be really nice to get, just even if it's a whole bunch of crap, I'll still play it all. I'll make a video with some gameplay footage and talking about, you know, the author and what's in the game, to help people, you know, decide what the vote is during the week of voting we're gonna have for the competition. And like I said, there's a cash pot at the end of the rainbow, so everyone should try out. Yeah. So yeah, if you guys ever want to get a hold of me, Twitter's the best way. I hang out on the Sega Extreme Discord all the time. I'm not good at following forums, but there's the forum post for the competition. Yeah. So I guess I'll see, hopefully most of you guys I'll see next week, but if you don't come on, you know, whatever, it's late. I get it, because I'm about to collapse. But yeah. If that's it, that's all my announcements. Just follow on Twitter for any updates to the game competition, if the prize pot increases or anything like that. If not, see you guys another time, and let's go ahead and raid someone. I'm part of the Pirate Crew network. Hopefully someone else on the Pirate Crew is on tonight, so we can raid them. So let's give that a shot. This is not a song I want to go out on. Let's go out on a nice song before I start raiding and send you guys over to someone else. There we go. Who can I raid? Who we gonna raid tonight, guys? Is no one else on tonight? That's weird. Usually someone is streaming something. Oh, there we go. Let's raid Russell Stewart. He's drawing stuff. People like art, right? Let's raid him. See you guys over there.